Very good morning, student. Today we can continue the topic of physics, that is the force. Okay. So yesterday we have learned some different types of forces. That is the real force and the pseudo force. Okay. That real force is the real interaction of these two bodies, but here if there is no real interaction of the two bodies, that is the pseudo force that we have learned. Means centrifugal force is the pseudo force, okay, while gravitational force is the your which force, that is the real force. So that we have learned. So after that, the different types of real forces, that also you have learned. So basically there are the four fundamental forces in the universe which are considered to be the real forces that you have learned. And the forces are gravitational force, electrostatic force, also that is also called as the electromagnetic force, electrostatics or electromagnetic, strong nuclear force and weak nuclear force. Okay, so these are the four fundamental forces are there. The which is the weakest force in the universe? Mostly there is a question which they can ask in the exam is which is the weakest and which is the strongest force. So the weakest force in the universe is your gravitational force, absolutely right. And which is the strongest force in the universe? Strong nuclear force, okay, which is the strongest. And how many times it will be more? 10 raised to 38 times it will be more than that of the gravitational force. While electrostatic force is 10 raised to 36 times greater than that of the gravitational force. Okay, so this is the comparison of that electrostatic force, electromagnetic force. Electromagnetic 10 raised to 36 times, electrostatics 10 raised to, or electromagnetic or electrostatics 10 raised to 36, strong nuclear is 38, and gravitational force is 10 raised to 0. So this is the comparison of that all these forces that we have learned. Today we want to learn basically the law of conservation of momentum. But before proceeding to that law of conservation of linear momentum, so first question arises, what is exactly momentum or linear momentum? So linear momentum is the product of mass into velocity. It is denoted by P, and P is equal to, that is mass into velocity. Okay, it is the product of mass into velocity. So that is called as your linear momentum. Okay. As this is the product of mass into velocity, so therefore naturally SI unit of linear momentum is kg meter per second. In SI system, mass measures in kg, velocity measures in meter per second. So therefore kg meter per second, this is the SI system, that unit. CGS system, that unit is gram centimeter per second. Okay, so these are the different units, SI and CGS system, of that your linear momentum. Once you got the idea about that linear units, then we are coming to the point, so what are the dimensions? So dimensions of linear momentum: mass m1, velocity l1 into t raised to minus 1. These are the your dimensions of that your linear momentum. Okay. So then the question arises, with this quantity is a scalar or vector? So this quantity is the vector quantity. Which quantity? This is the vector quantity. So this is all about momentum. Once you got that momentum, the next question is, what is impulse, or what is the impulse of force? Okay, which quantity I am talking about? Impulse or impulse force. Okay. So now impulse or impulse force is that physical quantity, or that means impulse force is that force which acts for short intervals of a time on a body. Okay, means that your impulse force, or the force which is acting for short intervals of time on the body, that is called as the impulse or impulsive force. Okay, the this is also defined as, impulsive force is also defined as, impulse is equal to force multiplied by time, force acting for short intervals of time. So therefore impulse is equal to force into time. So then now question arises, what is the SI and CGS system of impulse? Okay, in SI system, actually you know, that is impulse is the product of force into time. Now suppose a batsman hits the bat, and if any player wants to take that catch, then at that time while taking the catch, he is taking his hands behind. So what exactly he is doing? He is increasing its time, so that impulse goes on increasing. Okay, means for short intervals of time, whatever the force, if he is suddenly taking that catch, then there will be more impact of that your force which is acting on that body. But the same force can be reduced by taking the hand behind. So that is the impulse. Okay, means force acting for a short intervals of time. SI unit is Newton second, and in CGS system that unit is Dyne second. Okay, so these are the MKS and CGS units. So what are the dimensions of that impulse? Force measures in M1, L1, T raised to minus 2 and into T raised to 1. Okay, so here in that case M1, L1, T raised to minus 1. These are the dimensions of that your impulse. Now question is, sir, is there any relation between the impulse and change in momentum? Relation between impulse and change in momentum. Relation. Okay. Which relation you are talking about? Relation between the momentum, linear momentum and impulse. Linear momentum and change in momentum. Relation between the change in momentum and impulse. Okay, so now you have learned, so that impulsive force or force is the product of or force is nothing but rate of change of momentum, dp by dt. So what is the dp? Change in momentum means d dt of mv. Okay, mv minus mu. Okay, so that mv minus mu is the your final momentum minus initial momentum. If I will take the momentum, that means m common, then that formula will be force is equal to m into v minus u by t. Okay, and if I will take v minus u, okay, so then by t, that will be the acceleration. Okay, that will be the acceleration. So but now if I will take that v m into m into v minus u, or we can also say that mv minus mu, okay, divided by that time, that is also called as force. Why d dt of? Directly also we can write down. So this is the product of, that means dp means final momentum minus initial momentum, okay, upon time. Okay, so therefore final momentum will be mv minus mu, so that in upon time. So therefore force into time, that is equal to mv minus mu. Now force into time, that is also called as impulse. So therefore impulse is nothing but change in momentum. What is the another definition of impulse? Impulse is nothing but change in momentum. So that is also, our impulse of force is nothing but change in momentum. So therefore dimensions of impulse are same as change in momentum. Okay, so you just remember what is that your formula for the impulse and that relation between the impulse and the that your momentum. Okay, once you got this formula, then now we are coming to the point, sir, what is the law of conservation of momentum and how we can prove it. Okay, by using the Newton's third law of motion, that prove the law of conservation of momentum. Law of conservation. Okay, law of conservation of momentum. Okay, so that we want to learn, but by using the Newton's third law of motion. But now question is, sir, what is exactly Newton's third law of motion? Newton's third law of motion states that every action there is equal and opposite reaction. What is that law is telling? Every action there is a equal and opposite reaction. Okay, or we can say that if you are giving a force on the earth, then the earth will also apply the force on your leg. So therefore you are able to walk on the earth surface. That is a Newton's third law of motion. Okay, so now, sir, what is, how from the Newton's third law of motion we can prove the law of conservation of momentum. Now first of all, sir, what is the conservation of momentum? So the conservation of momentum states that if no external force is acting on the system, then when two or more than two bodies colliding with each other, then the momentum of that total system will remains always conserved, or total momentum before collision is equal to total momentum after collision if no external force is acting on the body. So that is called as law of conservation of momentum. Okay. So now, how we can prove that conservation of momentum means if initial momentum is equal to final momentum. Initial momentum is equal to final momentum. Okay, so that is the law of conservation of momentum. Okay. Now we want to prove that law, but when there is no external forces acting on the system. If you want to prove this law, then what you have to do? You have to consider, suppose there are the two bodies having the mass m1 moving with the initial velocity u1. Okay, this is the body A. Now the second body which is moving, body B, which is moving with the velocity u2 having the mass is m2. Here in that case u1 is greater than u2. Velocity of first body is greater than velocity of second body. So as the velocity of first body is more than second, then after some time, so what will happen? This A is going to collide on B. Okay, so this is called as time of impact. This is called as time of impact. Okay, or time of contact. So now after A and B they are colliding with each other, then now after collision they are going to separate from each other. A is moving with the velocity v1 and body B is moving with the velocity v2. Body having the mass m1, body having the mass m2. This will be the before collision, and this is the after collision. This is after collision. Okay. So now here in that case we want to prove that law, the conservation, initial momentum is equal to final momentum. Suppose m1 is the mass of the body, body A, and u1 is its initial velocity. So the initial momentum of first body will be body A having the initial momentum m1 u1. Body B having the initial momentum is supposed to be m2 u2. Okay. And so therefore the momentum of the system, total initial momentum of the system, total initial momentum, okay, of system is m1 u1 plus m2 u2. Okay, so this is the total initial momentum of the system. Okay, suppose during the time t these two bodies they are colliding with each other, and after collision that their velocities are going to change as v1 and v2. Body A will acquire the velocity v1 and body B will acquire the velocity v2. Okay, so this is the condition for before collision. And now if I want to say, that means after collision, okay, after collision what is going to be happen? Okay, after collision, so body A have the momentum m1 v1, body B have the momentum m2 v2. So therefore total final momentum of a body is equal to, what will be that momentum? m1 v1 plus m2 v2. Okay, so this is the second equation. Okay, now once you got that, after collision, before collision, after collision, then what exactly we want to prove? The momentum before collision will be same as momentum after collision. m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. That we want to prove. So for that what I will do, suppose when that during the time of contact, okay, or when the time of impact is so small that as compared to that collision, that after the collision means according to that observer this time is still very small, means time of impact within a fraction of a second this incident happens according to who is observing that incident. Okay, so that t is very small. So therefore when the body A applies applied force on B, then magnitude of that force B, A exerts force on B, will be, what is the mass of that body? M2, mass of the body will be M2. Okay. Then their final velocity will becomes V2. U2 becomes V2 minus initial velocity was U2 upon time T. So therefore F into T is equal to M2 into V2 minus U2. Okay. So that is the your third equation. That is the third equation, F. But now when the body B, same times body B applied the force on A, okay, the body B also applied force in opposite direction, but opposite direction on B, direction on A, okay. मुलांनो, हा जर याच्यावरती फोर्स टाकत असेल तर हा याच्यावर पण टाकतो, पण याच्या डायरेक्शन दोघं कशा असतील एकमेकांना अपोजिट डायरेक्शन. ओके, हा इकडून टाकेल आणि हा इकडून टाकेल मुलांना. हा एफ असेल तर हा तुमचा मायनस एफ असेल. ओके, लक्षात घ्या मुलांना. ओके, आता what will be that force? So then that F is equal to force exerted by B on A will be first body mass M1, final velocity V1, initial velocity U1 upon time T. So therefore F into T is equal to M1 V1 minus U1. Okay, but now that sign will be negative because this force is in opposite direction. So this is the Collat equation number 4. Okay. Once you got that third and fourth equation, okay, then we can, that means solve this equation. Which equation now? By solving equation 3 and 4, from 3 and from 4, from equation 3 and 4, what we can say, Ft, LHS are same, therefore RHS will also same. M2 into V2 minus U2 is equal to M minus M1 V1 minus U1. Okay, and now after solving this equation, so you will get now here, okay, so what is that equation? M2 V2 minus M2 into U2 is equal to minus M1 V1, okay, plus M1 into U1. Now what I'll do, I will take this term here, M1 V1 plus M2 V2 is equal to M1 U1 plus M2 U2, or M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. And so this is the conservation of momentum. Okay, so this is the law of conservation of momentum. Initial, which is what is M1 U1 plus M2 U2? This is the initial momentum of the system. And what is M1 V1 plus M2 V2? This is the final momentum of that system. So this will be the law of conservation of momentum. Total initial momentum is equal to total final momentum. Okay, total initial momentum is equal to total final momentum. Now you just remember this law can be applicable for very large object also and very small object also. Okay, means when the collision is between very large object or between very small subatomic particle, this law is applicable. Second, the body is moving in different direction. Not necessarily they should be always moving in the same direction. If they are moving in opposite direction also, this law can be verified. As well as when the two bodies are moving along the same straight line before and after impact. Okay, or they are moving along the same straight line and after impact also they are moving along the same direction, but only velocities are going to be get changed. So this is the way how we can prove the law of conservation of momentum. Now question is, sir, which are the different examples of the conservation of momentum? Okay, so now these examples are particularly, if I will take the, that means theoretical examples first. So The first example I will take here is like this. The example of gun, okay, and bullet. Gun and bullet, okay. Gun and bullet. So what is the example of gun and bullet? Suppose we have been fired, okay, we have been fired the bullet from the gun. So initially the gun and bullet have the same momentum. How much momentum? Because both they are in the rest position. Bullet is also in the rest position, gun is also in the rest position. So therefore, when they are in the rest position, the initial momentum of bullet and gun will be 0. Because m1 u1 plus m2 u2 will be 0. But as soon as we will fire the bullet from the gun, then now the bullet is going to move with very high velocity. That is called as the muzzle velocity of the bullet. What is the word? Muzzle velocity. And the gun is going to move with the very small velocity, and that is in opposite direction of the velocity of the bullet, and that is called as the recoil velocity of the gun. Okay, so therefore both they are in opposite in direction, and when I will take the momentum of that system, so therefore first of all initial momentum is 0, final momentum m1 u1 minus m1 m2 v2. Okay, this is the gun, this is the bullet, and so therefore we can say m1 u1 is equal to m2 v2, means mass of the bullet into velocity of the bullet is equal to mass of the gun into velocity of the gun. So there will be a conservation of that bullet and gun system. Then we can take the bomb. Okay, so if suppose if you are taking the example of that bomb, okay, sir, how the example of bomb will be there? Suppose initially bomb is in the rest position, means initial momentum of the bomb is 0. But as soon as I will throw this bomb, then what is going to happen? You know that bomb is going to split with the different fragments, and all the fragments they are going to move in a different direction. But if you will take the vector summation of all these masses of that fragments and their velocities, they are going to cancel the effect of each other. So therefore total momentum of the bomb is 0 and final momentum of the bomb is also 0. Okay, so therefore initial momentum is equal to final momentum. So these are the different example, theoretical examples we can take for that your momentum. Once you got that examples, then we are coming to the point, sir, what are the numericals on that your momentum, impulse, okay, law of conservation of momentum. Okay, I will give two to three examples to you. So you please write down that example. First is, suppose a force acts for 8 seconds on a body. Okay, force act at 8 seconds continuously acting on the body. Okay, and of a mass 10 kg. And what is the mass of the body? That is supposed to be 10 kg. Okay, and the force then stops acting on the body, describes the 80 meter in next 5 seconds. Okay, and then after that the body covers the distance of 80 meter in time of 5 seconds. 80 meter distance in next 5 seconds. Find the force. So what will be the force acting on the body? So here in that case, but the force is equal to mass into acceleration. If you want to find out the acceleration, then what exactly we have to do? For that you have to find out the velocity, final velocity. How we can find out the final velocity? Final velocity will be total distance covered 80 meter upon time taken to cover the distance. So that is the 5 seconds. So 80 by 5, that will be the 16 meter per second. So that will be the final velocity. Once you got that final velocity, then you have the kinematic first equation. V is equal to u plus at. And so now the final velocity of that body will be 16. Initial velocity is 0. A we want to find out, and the time which is acting on the body is for 8 seconds. So therefore 16 is equal to 8a. A is equal to 16 by 8. That is equal to 2 meter per second square. Okay, so as the acceleration is 2 meters square, so therefore force acting on the body, if suppose you want to find out, so that is equal to mass into acceleration. Mass is 10, acceleration is 2, so therefore 20 Newton is the force which is acting on the body. Okay, if you want to write down the similar question, a force acts, okay, for 10 seconds on a body. Okay, force acts 10 seconds on a body having the mass is supposed to be 20 kg. Having the mass is supposed to be 20 kg. Then body describes 100 meter. Okay, it describes how much distance? 100 meter in next how many second? After stopping the action of force in next 5 second. Okay, 5 second only. Then what will be the magnitude of force? Okay, you will be able to do that things. You can do the same thing. Okay, you can do here 100 divided by 5. So that is going to be 5 twos are means 20 meter per second. V is equal to u plus 80. So the final velocity is 20. A into and t will be 10. So therefore 10A is equal to 20, and so therefore A is equal to 2 meter per second square. Okay, therefore 20 by 10, that is equal to 2 meter per second square. And here again, so mass into acceleration, mass will be that is 20 kg and acceleration will be 2, so therefore your force will be 40 Newton. Okay, so again one more problem you can take. A constant force, I will rub this second problem. Now suppose one constant force, okay, second example, a constant force of 200 Newton, acts for 10 seconds, okay, acts for 10 seconds on a body initially at a rest, means initially that velocity of the body is 0, and the mass of the body is 50 kg. What is the mass of the body? Mass is 50 kg. Then question is find the acceleration of the body, or acceleration produces on that body is. So now you have the formula, force is equal to mass into acceleration. Sir, how long that time, that means you have given at the 10 second, that means the force has been applied on the body, initial velocity 0. It means that means it is not playing any role. So therefore acceleration is equal to force upon mass. So force will be 200 Newton upon mass will be 50 kg. So therefore 5 is a 5, 5 2s are, means acceleration will be 2 meter per second square. How much that acceleration will be there? 200 by 50, 5 4s are. Okay, so therefore correct answer is 4 meter per second square. Okay, so this is how you have to solve this question. Next question, you please take this. Last question, suppose this we can consider. So now suppose, for example, fourth question. Okay, or third question, 1 2 3 4. Okay, fourth question. A constant force of 400 newtons, okay, acts on a body initially at a rest, means u is equal to 0. Initial velocity of the body is 0. Till the velocity of the body becomes 32 meter per second, means final velocity of the body is how much? 32 meter per second. 32 meter per second. Okay. Then now the mass of the body is 50 kg. Mass of the body is 50 kg. Then question is find first question, find the time for which the force acts. The time for which the force acts on the body. He is asking you time. And second is impulse or impulsive delivered by the force, or impulse we want to find out, delivered by the force. Now sir, if you want to find out the time, so now you have the formula, you have the F. But what is the F? F is equal to change in momentum upon time, mv minus mu upon t. So you have the mass, so therefore what I will do, m I will take common, v minus u by t. So force is acting on the body is 400. Mass of the body is 50 kg. Final velocity will be 32. Initial velocity is 0 and you want to find out t. So therefore t is equal to 50 into 32, because 32 minus 0 is 32, upon 400. So therefore 0 0 will get cancelled, and so therefore your point is that 4 ones are 4, 4 eights are 40, and 8 fours are, means time is equal to 4 seconds. First answer is time is equal to 4 seconds. And the second question is find the impulse. So now for calculating the impulse, I will say impulse is nothing but force acting for short intervals of time, F into t. So if this is F into t, what I will do, the force will be 400 and time required will be 4 seconds. 4 fours are 16, 1600 Newton second is your right answer. Okay, so these are the different examples. Then now we can, next period we can take the work. Okay, and then after that there is a related with the work, which are the different types of works. Okay, or we can also find the variable work done due to the variable force, constant force, work energy theorem. Okay, and there is one more, that is collision. So that part we want to learn in next period. Okay, today we'll stop here.